Hey everybody, we are back with Simon, and I'll let you say your last name.
It's Podhajsky. The mnemonic for it is if you smoke pot, you will get high and you shouldn't go ski. Podhajsky.
Brittany's losing it in the green room right now. I did not see that coming. I think that's perfect for my introduction for you. This is an individual who is so funny and so smart at the same time that I'm half the time I'm laughing and half the time I'm like it's like maybe too smart for me to be like to catch on with it, but he's a guy I've enjoyed talking with every other Friday for a long time at the OA Coffee Club, or whatever we call that. Again, another plug for that. You should join us. He's always just an interesting take, and will and some good lighthearted jabs along the way. He is data lead at iLife Technologies. Congratulations on the recent kind of promotion to the lead role there. I've seen you asking a lot of really interesting questions over there. And then uh, it says data everything at a seed stage company, formerly data scientist at SRI International Center for Health Sciences, data manager at Stanford's Department of Psychiatry, and postgraduate associate at the Yale Decision Neuroscience Lab.
That's
What are
all
we
me.
gonna do? What do I do with all this, man? Um, I just want to remind everybody that after this talk, there will be a live chef leading a virtual cooking class in the lounge after this session. But that's aside from now. I'm really excited about hearing this. This seems like so far from the way I live my life that I think we're gonna all have a lot to learn. Simon, I'll let you take the stage. I'm looking forward to it.
Thank you very much for your kind words, Trevor. Um, I just want to point out for anyone who was coming to this talk, seeing that it was neuroscience for MDS. In this case, MDS stands for modern data stack and not the major depressive syndrome. That's another talk entirely. It is kind of funny how analytics engineering and the entire analytics world has a lot of overlap in acronyms, DBT and dialectical behavioral therapy, all that jazz. But I suppose there's only so many three-letter acronyms to go around. So in my talk, I will talk about two main things, or have two main audiences. And there's a poll for you to let me know what audience you are from. Um, First, I want to talk about what it's like to jump from academia to industry. And if you've just made the jump, what to expect. And I also want to talk to the people who want to hire from academia, which is not entirely the standard hiring funnel. And I'll sort of let them know what to expect and what their new hire will be experiencing and how to make things better for them. Um, Mostly I'll talk about what's different between academia and industry and how to hire from academia. So two parts. As for who I am, I have worked in neuroscience and machine learning research until very recently. Um, at Yale, I did a little bit of neuroeconomics. At Stanford, I work in the neuroscience of addiction, where we got rats drunk, and continued that work at SRI, which is basically Stanford, but more corporate. Um, I've been an industry shill since 2021 at a tiny startup called iLife. And there I've been leading a data team of two to basically build up an analytic data stack with mostly what we call the modern data stack and not the Microsoft stack or anything. So my experience is mostly from there. But necessarily it is personal. As a researcher might say, I have a sample size of one. So take that with a grain of salt. So before I jump into what's different, I want to motivate a little bit of this talk for whoever might want to hire from academia. Why you should hire researchers. Well, they do data and they know what data means. This is what might be subsumed under critical thinking, the fact that you understand that data is not the ground truth, that it's a indicator at the search of the truth, and there's limitations associated with it. For more, go watch Josh Richmond's autobiographical talk from day one of Summer Community Days for an example of how awesome an academic hire can turn out to be. But also often in the quantitative academia, people will go the full cycle of data prep to data transformation to data analysis. They have to be pretty resourceful about how they go about doing that. And they often do that in teams. So it's a pretty good fit for most data roles. Now, I promised that I would talk about what surprised me and what's different, why you can't just take a person from academia and slot them into the data team and have them hit the ground running from day one. And my favorite complaint is something called data as exhaust, something I've been calling that. Basically, the difference is that in academia, you collect data to analyze data and then write a paper or a grant, and then you're done. And the purpose of the data has from the start been to facilitate an analysis. So whatever problems you run into in industry, where entity resolution is going to be a problem because all of these different systems that a business is using are using a different identifier for each of your customers. And often the data that you get from these services will need to be change captured, but as it stands, it only reflects the current state and has no change hooks. And there's no guarantee that the data schema will not change on you. Those are the sorts of headaches that you deal with when data is not the primarily analytical thing, when data is just a tool to make the business work. And you have to make your peace with that this is why you're getting hired. If you're in academia, this is why you're hiring someone from academia. You're trying to make the business run better, but the systems that the data come from have not been architected from the start to be analysis centric. They sort of emit data as exhaust, and you have to make sure you are ready for that. And there are stages of being ready for that. The first stage is the stage of shock. Then you sort of move on to the dark stage of acceptance, where you become to understand that this is just how things work. And finally, you become comfortable and sort of point at the trash fire and say, this is fine, and you should be fine with that. But it's a challenge, and it's going to be a challenge for you as well, unless your data architects are really very good from the very start. The other difference is that data never ends in business. And this is something that's very different in the academic data cycle, which isn't really so much of a cycle. In academia, you start by collecting data, then you process the data a little bit so that you can stick it in R or Python or MATLAB or SPSS or whatever. You analyze data, you write a paper or another grant to get more money, then you forget the data. If you're a good person, you also publish the data before you forget the data, but mostly people just forget the data. This is a little bit different for longitudinal and cross-site projects where you might be collecting year after year, and so it will take a little bit longer for you to forget the data, and there will be more papers written on it. And so this is something to be looking out for in your data hires. If they have experience from longitudinal projects, that will be a little bit easier for them to handle the fact that businesses run differently. Businesses primarily run. They generate data that are critical to the business, and also secondary data that are just adjacent to the business. If you have a business that gets customers, you sort of have the database with your widgets, and also probably HubSpot or Salesforce or something, where you have to keep track of the customers, and maybe you have Segment or Snowplow or something to keep track of the events on the website and all that jazz. And what you do with that is you extract and transform and load it and then do analysis on it. But the problem with this is that once you extract insights, they go back into running the business and the cycle continues. There's never any forgetting the data. And if there's a schema change in the middle, that's something you have to deal with. If there's a new system that generates data, that's something you have to deal with as well. So this is something to be a little bit wary if you're coming from academia. In academia, you typically won't be dealing with cyclical data. You typically won't be dealing with real-time data. And that's something that businesses eat for breakfast. Finally, a distinction that I've noticed is that the academic data stack is different. And this has to do with orchestration, pipelines, and storage. There are specific tools in academia that are often specific to the type of data that you deal with. Often because there's not really a data cycle, you don't really need all that much orchestration. So Airflow and Dexter don't really make that much of an appearance unless you're in a longitudinal project. And finally, and this one is the biggest breaker, there's so many CSV files everywhere in academia. And that's something that you luckily won't have to deal with as much in industry. The fact that things run in the cloud, there's a database that's probably optimized and indexed. That's the sort of a thing that's different. That's the sort of a thing that will mean that you also have to approach it differently and probably with slightly different tools. And the tools are not dramatically different, but they are different. So be ready for that. So that's the first part of the talk, the differences that I experienced and the surprises that I've experienced. In the second part, and this is a little bit more speculative, I want to feel my way into the field of a hiring manager and see what to hire for. And there, the first and the main question to ask is, what position do you actually want to hire a person from academia for? What's your need? Because things will work much more easily when you're hiring, and this is kind of a general hiring remark, if you know what you want the person you're hiring for to do. So scoping down things into a data analyst or a data scientist or a data engineer role is definitely recommended. As I meant, maybe do not hire the person as the first data hire unless you have a really long runway for them. I mean, I was the first data hire at my startup and I'm happy with that, but it's been a journey. And so I'll think twice if you do that. I want to also note that both individual contributor roles and management roles might both work, in part because often if someone's done a PhD, they've done a bunch of projects that have had a bunch of collaborators, perhaps across many sites. So they might be used to shepherding people through projects and setting and managing them and mentoring them. So don't knock that until you've tried it, and consider trying it. There are also things that you might be tempted to look at that I think you should overlook when you're hiring from academia. Specifically, researchers won't know things, but they're quick to learn. Typically, very few people in academic research know SQL. They will transform the data some other way, but typically, since they mostly deal with CSVs and not by way of DecDB or anything, mostly this will be via Pandas or Python or R or dplyr or some other, or even Excel. And they should know how to deal with dirty data if you're trying to hire them, but they don't need to know SQL right away. SQL is pretty easy to pick up. The other thing to be tolerant of is ignorance of industry-specific stacks. Probably the researcher that you're trying to hire will not know what dbt is, might not have caught up with Dexter, might not have heard of Airflow, but probably knows that you need to run one script after another and log their outputs and deal with their errors. So don't sort someone out just because they don't know what Airflow is. And lastly, an academic researcher will probably know, well, neuroscience or monkey brains or sociology of political expression or whatever, but probably not your specific domain. For instance, I knew very little of life insurance before I joined my startup, but they should be interested in learning about it. That's, I think, more important than them not knowing what it is. Conversely, on the things to look for stage, a lot of researchers will have a lot of transferable either technical or statistical knowledge, they will be very open to learning more and more things, because someone doesn't stay this long in or around school if they don't like to learn. Um, a lot of them will be interested in reproducibility of analyses or open science, even though hashtag open science has sort of a mixed reputation these days, so that's not a necessary thing. But basically making sure that things run and run reliably and predictably often becomes an obsession for some of us. And finally, look for people who have organized collaborative projects and who have taken part in longitudinal projects, because those are going to be more similar to the business data cycles than they are to the academic linearity. And I believe that is it for me. I'm afraid that I'm cutting it a little bit short, but I'm very excited for any questions that you might have. Trevor, please come back.
That was great. I'm not from an academic background, but I feel like as I transitioned from like somebody who went to college and was interested in data to like getting a career more in data, I traveled along a lot of these winding paths that people are like, oh, do this, do that, do that. And it's like so much of it is just like that's not useful. And I'm glad that you kind of like separated the wheat from the chaff in regards to like what are the actual things that you're going to need to know to be effective at a job or to hire that person so that they can be. So I appreciate you doing that. Excuse me. I'm like, let me just check a Q&A here. The question I have for you, you're totally right, and like CSVs rule everything around me. The acronym CREAM, we'll put on a shirt eventually, I'm sure, um, is so sad but true. And SQL is actually what really runs businesses. What did you? How did you manipulate tables in academia, and what did you use to learn SQL and translate? Like, what was your Rosetta Stone for getting from that to that?
Awesome question. So mostly I have used pandas and dplyr when working in Python and R respectively. I know people who do magic with Excel and even convince it to not mangle numbers into dates along the way. If you are from an R world and you use dplyr, I can't recommend heavily enough a library called dbplyr, which can translate your pipes and pipe commands into a series of SQL commands. So you can basically see what's happening there. And I'm going to plug a little bit my talk at Coalesce a couple months from now, where I will go a little bit over how you might bring in the modern data stack into the CSV world and use Daxter and DuckDB and DBT to do the very same thing that you might be used to doing otherwise.
Wow, that is oh man, that's crazy. Um, I, I'm trying just to envision what that would be like. Is it like just a bunch of seed files then, or can we get a little preview of that?
Absolutely. So the preview is you take the CSVs that you'd otherwise be read.csving into whatever system you are, and instead you load them into DuckDB. Perhaps you assign indices if you have multiple tables, perhaps not. And then you run SQL over that with the dbt SQL adapter.
Sorry, go on.
And if presumably you have additional analysis downstream that you want to run, presumably you might be trying for a mid-collection analysis. So there's also going to be some preview of dbt snapshots and orchestrating everything with Daxter and their fancy new asset management approach. I'm looking forward to actually making it happen. I only have a very tiny demonstration right now that I'm not quite ready to unveil. But thank you for asking.
Yeah, I'm glad that you're doing this. I mean, we need more of this. I don't know if anybody's going to be like, given everything that you've said about like, a lot of it's not reusable, so you don't need to worry about it. We're going to throw it away. If you publish, that's good for you. to apply DBT, I think it's going to be a fun and interesting hack. I'm ready to watch this talk, but it's going to be an interesting one. You mentioned a couple of times. Oh, go on.
No, please go ahead.
You mentioned a couple of times DeckDB.
That's
Is
right.
that
So
the name?
DuckDB, you may or may not know from Twitter, is the new hotness. It's
Wait, is it
basically
Duck or is it DE or DU?
DUCK,
I got it. Okay,
like the animal
go on.
that quacks.
Yeah, tell us.
Yeah. It's basically a snowflake that you can run locally. I think that would be my like it's an analytical database that can execute vast analytical operations quickly.
Okay.
It is to let's say that local databases go, SQLite is to data ingest as DuckDB is to data analysis. So it's basically a way to run SQL on your local data if you don't want to or can't upload the data into the cloud for privacy reasons or private health information reasons, that sort of thing.
It's really, really interesting. No, I've heard of it, and I never paid attention because I haven't heard of it described in that way. We have one of our OA club folks asking a question here. What is an example of how your academia critical thinking became an extra crucial or helpful in the I can't read anymore. What is an example of how your academia critical thinking became an extra crucial or helpful in? I'm throwing an A. Sorry. Helpful or critical in the space. Have you found the testing done in academia research is applicable in the testing? Okay, you read the question. Just answer it.
Yeah, right. Have I found the testing done in academia applicable in the testing for issues in the modern data stack? Somewhat. I'm not sure I have an example of how the critical thinking, I suppose talking to stakeholders, I find it a little easier to state the limitations of whatever analysis I'm presenting, just because I'm used to the papers having a limitation section that's pretty long. And it's second nature to second guess what the data tells me and what I can say about the data. As for the testing, this is something that I really want to bring more of into academia because data tests are relatively uncommon there and much easier to do with both DBT data tests and the DBT unit testing package, which lets you unit test the SQL models themselves. So I suppose that this is a thing that I should have remembered, that data testing is quite often a blind spot for researchers. They might not know that automated testing exists for data. They might be used to doing that sort of manually or on an ad hoc basis. So thank you, Nicole, for the question.
I think you brought up a really interesting kind of dimension to this that I don't think really addressed in your talk, but you mentioned stakeholders and stakeholder management. And just really quick, let me plug. After this, we have a live cooking show. I'm not kidding. We're not cooking anything up in SQL. We're not cooking up anything in code. We are actually cooking some type of French meal. So for those of you in 5 minutes, hang tight for that. But I think to me the interesting question is dealing with stakeholders in academia versus dealing with stakeholders in a business context. How do you distinguish between the two? Did you learn one thing from the other? Did you let go of things from this to that? How do you think about that?
So I think that stakeholders in academia are a little more used to null results, and they're not happy with them by any means, but certainly business doesn't stop if your analysis doesn't find a significant result. Whereas if you're working with stakeholders who assign you to do a statistical analysis, they often expect that analysis to confirm what they already think they know. And so the work of communicating the limitations and setting up appropriate skepticism, and following the data where it leads is very important. But also, the stakeholders often have a reason to believe that the data will say something. And if it's not saying that something, then it's possible that the data has not been correctly handled or transformed or modeled because, as I mentioned previously, your data is exhaust oftentimes in a way that must be handled. So this both respect and communicating limitations towards stakeholders, those are very important lessons for me.
I think continuing on that thread, it seems like with stakeholders with impact, there is this notion of ethics, which I think is often very much considered in the role of academia, but like I'll give people data that points in a direction that I just want them to take. I'm not shy about that. Like, do you have a different? Do you have a different sense about like ethics and like null results and like do you lower? Hopefully, I'm using this right. Do you like change the p? Do you hack the p value in order to like give something that may push in the right-ish direction?
I personally don't change the alpha, and I don't say that something approaches significance when it's not significant, but I understand the pressure for that. I think that the more important job of the data analyst and analytics engineer and or whatever other role you end up in is just making sure that the right questions that make a difference are asked, where you don't mind if you get a null result, because that in itself is a reasonable output of your
Yeah,
analysis. And that's, of course, difficult.
that was.
Um, and I myself struggle with this, but that's what I aspire to.
No, yeah, I think that's the difference. I think of leading in a role as a data person versus kind of just like being a doer in that role of like how do I get people to think in a particular way that we're going to be able to use data to like justify or to guide their decisions. Um, changes the makeup of an organization versus just like changes like like little tweaks in here around the edges. So I think like I'm really glad that you said that. I mean, so what you're saying is like despite holding on to your ethics, you can hold on to your ethics and still provide or rigor in data. You can still provide a lot of benefit to an organization by just helping them think a little bit better about data, ask right questions. I think that's like enormously valuable and good advice. So I'm glad you brought that to us today.
Thank you for
Uh,
asking the right questions.
well done, funny and always on the spot. So this was a chat with Simon. Oh wait, I remember. Pot.
It has to do with
Shoot.
weed.
Yeah, no. Well, pot ski. Pot. What was it?
Hi, Podhajsky. Thank you for trying.
Podhajsky. So Simon, this has been good. We have on our in the next 30 seconds we will have a cooking show, and I don't know what to say about that, but I guess one last plug for your DBT talk. It's can you tell us the title of that one?
Um,
Maybe not a title yet.
I'm sorry, I'm blanking on the title, but it's a DBT coalesce in late October. So
Okay, awesome. And you can reach out to him. Oh, you can. It's all good. You don't have to have a firm title just yet, but it sounds like an interesting one. You can reach out to Simon in OA Club, and I'm sure he's very available on LinkedIn as well. Again, we'll be back in 30 seconds. Thanks, Simon, and thanks for staying up late because I think you're in Eastern Europe right now. You're in the Czech Republic now.
that's right. It's 10 p.m. It's fine.
Great job. Well done. I appreciate it. We all do. Thanks, and we'll see you soon.